Hola, clase. Hopefully, everything's going okay for you guys at home. It's Mr. Hess. This is a discussion of testing a sample proportion. If you haven't figured it out yet, Unit 6 is all about formulas and how to do these with analytical methods instead of StatKey to simulate results. Just another method to get a similar result. Certainly, I wish we were in class together. Miss you guys. Hope everything's doing okay. Do your best to reach out to each other. Stay connected with people you might be concerned with. And let me know if there's anything I can do to help or anybody I can put you in touch with that could help you. So hopefully this is going okay. Let me know. I think my videos are a little easier to read than the textbook, but we'll see. So there'll be a PDF version of this on Schoology and a couple part video that goes with this. So first question on your paper there, jot down what you remember about a z-score formula. And hopefully you remember most of that formula. You want to find how far apart a point is from the mean, which is what this top part's doing. And then you want to standardize that. You want to divide it by the standard deviations. That's one version of it. You could have the X bar and S version of it too for a sample instead of the population. This is one version of that. So we want to update that. The other question here, how do you calculate a z-score? How do you calculate a z-score for proportions? If you just tweak this a little bit, you think about if we're doing a hypothesis test, where's the center? Mu is the center. Where's the center for a hypothesis test? And of course, you probably remember that's the null. And when we're talking about standard deviation of this, what do we call that when it's a sampling proportion? We call that the standard error. So if you imagine changing this z formula around a little bit to making this p hat for proportion, this is going to be the null proportion that we're comparing it to, seeing how far apart those are. And then we use standard error because we don't have a standard deviation of the entire population. That's the next version of this formula. Here's the final version of it in terms of specifically for p. So you got your sample statistic, which we said before is p hat. You've got subtracting this p0 here, which looks just like that p0 there, or h0. That's your null proportion. So whatever you think is going to happen if there's nothing statistically significant going on. And at the bottom of that is that new standard error formula that we've been using in the last couple of homeworks that you're hopefully starting to get familiar with. So the only dilemma we have to sort of worry about now is this, if my cursor comes up here, this p and this p here, we got to decide, do we use p hat or your null hypothesis? And the answer for that is a conservative one. We want to use the null hypothesis. It's a conservative way of getting the standard error. It's the most conservative way of getting the standard error. It'll get you the biggest standard error. And if you make this number big, it's going to make the z value small, which is giving you sort of a conservative estimate of how significant your statistic is, your sample is. That's the idea. And again, p naught, or p0, is the null hypothesis proportion. The null proportion, you could call it that, I guess. Second part of this, you still got to check the central limit theorem. You want to make sure the sample size is large enough. If I was in class, I'd say, how do you check if the sample size is large enough? And somebody'd say, well, NP has to be greater than or equal to 10 when you multiply those. And I'd say, well, what's the other version of that? You got to check both. Check, both extremes. And that's if n times 1 minus p is also greater than or equal to 10. Now we run into the same dilemma. We got to decide, are we using p hat or p naught for this? And again, we take the conservative approach and we use p naught for both of these. Last part of this is to verify. Can you verify or validate the hypothesis that we're testing here? So if you think back to how we verify hypotheses, pretty easy thing to do. And if I was in class, I'd definitely ask, how do you verify, how do you measure a hypothesis? How do you see how extreme the hypothesis is? You probably remember we do that by looking at p-values. So we go from z to a p-value. And then I'd also ask you something about high p-values versus low p-values. If you think about the distribution, where is a high p-value? Way out here is not a high p-value. That's a high z-score. Z is down here. That'd give you a low p-value, a low percentage chance of happening. Low percentage chance of things occurring are extreme. They're significant. They're interesting. As opposed to p-values around here, which are very high p-values, high probability of them occurring. They're close to the null. So a little refresher on that. Hopefully you can see that on your page. You know, if you got a low p-value, you're way the heck out here, or you're way out here, depending on the hypothesis. You got extreme values. That's telling you reject the null. Something is happening. Something interesting is going on. We're interested in what the study is. So, quick little reminder, take out your, if you can do this on StatKey, it can be done on StatKey. I'm going to suggest you instead use this thing. This is sort of the rough version of that. You're used to seeing it more like this. You're going to want that Z table that you have, 2 of those in your possession. Have those handy because you're going to be looking up Z values to find a P value over here. These are all probabilities of something occurring, assuming the distribution is normal. So try that on this first one. I'll come back in part 2 and see if you've got something, set of hypotheses tested correctly.